All right. Well, welcome everyone to What's Up with the Taylorville High Net Zero Pretty Good House student build. This is an exciting session where not only are we going to focus on some building science and technology, which we always love to do, but also equally and very important is the education and training of our next generation, not only to ensure that we have the workforce that we need with good paying jobs for those coming up, and to help fulfill our housing need and our housing crisis, but also to ensure that the construction is done right from the start so we can have a more sustainable built environment. So I'm really excited to have this. Now, before we get into this session, I do want to say a huge thanks to our top tier sponsor, Build Equinox. Build Equinox is one of our gold level sponsors, and they have a feature of the Serve 2 and the Serve 1000 for schools. Now, these devices are like energy recovery ventilators that keep fresh air coming in, exhausting stale air, but they're a little different. They've been integrated with heat pump systems for maximum comfort. They're also demand controlled smart ventilation, which then detects poor air quality and then exhausts or ventilates or filters that poor air quality as needed, which is also another energy saving feature and prevents overventilation. You can learn more about the Serve 2 and the Serve 1000 over at buildequinox.com. Now, this session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. Today, I will be your moderator. My name is Brett Little, and I am the education manager here. As all of our courses are, this one is approved for multiple continuing education units, including our certified green home professional designation in all 5 pillars of green, as well as AIA health, welfare, and safety, which may make it applicable to your state-based design or contractor license. Make sure you grab that 5-digit passive house code at the end. It'll be sent to you if you're appropriately logged in and stay for the entire time. You can use that to submit your certified passive house consultant designation. All right, so with that, I am very excited to welcome our speakers and hand it off to them. Now, Ty Newell's no stranger to our show. I can't even remember how many times you've been on now, Ty. I mean, maybe we're on our 5th or 6th time at some capacity, whether doing a session, leading a session, or being a part of a panel. And you've been to some of our live trainings as well. So, Ty, it's always exciting and a pleasure to have you on and speaking. And then also we have Matt Bloomquist here as well, talking about his work in teaching the students at the Taylorville High. So with that, I will hand it off to both of you to introduce yourselves, and please take it from here.
Matt, I was trying to remember. I think we met over a GHI webinar. And
yeah.
and I think it was actually on Pretty Good House, maybe with Emily or something. And
there was a lot of us on there that day. Yeah.
And I was thinking, you're over in Taylorville. Well, damn, that's not too far from me. I'm in Urbana, so we're in central Illinois. And so that's kind of how we hooked up together, was from GHI. And then, we're talking about the Pretty Good House, and then this exciting project that Matt's leading over in Taylorville, Illinois, and lots of folks participating and helping out. Emily Mottram, one of the co-founders of the Pretty Good House movement, Mottram Architecture out of Maine, who graciously donated a wonderful house design for Matt then to take off and demonstrate here. Net zero is real. Cold temperature heat pumps are real, and here's some other exciting things that we'll be discussing. And then myself, I'm over in Urbana, and where my background's more heat pumps and energy, building science, monitoring homes and energy they use since the mid-70s, back when we used to sit there and just literally click through temperatures with a dial to now where we can do it remote.
I'm Matt Bloomquist. I'm the building trades teacher here in Taylorville High School, where we do build a house. And when we relaunched this program that we've had since 1969, I put an emphasis on building better and building science. And I knew only a handful of things about, and then had to go figure that all out. So I learned with the students.
We won't spend a lot of time on that, but I mean, that movement is flying high, and thanks to Emily and her co-founders of the Pretty Good House movement. Actually, here's the book they wrote, a lot of good practical guidance on it. And you know, for me, I think probably about 5 years or so ago, prior to 5 years ago, say 10 years or so ago, I'd hear people going, yeah, I'm building a near passive house. They didn't want to go through all the certification, but they were learning on their own in whatever manner, maybe taking workshops. And, you know, and our passive house friends have done just a wonderful job educating people on a lot of great ways to build a house, envelope and everything with that. And then I started hearing maybe 5 years ago, people are going, I'm going to build a pretty good house. I'm going, oh, that's kind of nice, pretty good house, you know. And I started hearing that more and more frequently, where it wasn't just a coincidence somebody's using that term. And then Emily had a webinar on GHI, and so I signed up and listened. Oh, okay, now I get it. It really is, and that's, you know, as we connected up. But it's really taken off, and it's an interesting concept that, you know, it's common sense. Let's look at the economics. How much do we want to put in insulation? And then what do we get for that extra insulation? How much are windows costing, and what's the economic impact? But trying to combine the considerations of the materials, how healthy they are for us, how sustainable they are. And then on top of that, how to reach a high level of performance, but one that's cost effective. And then combining that with a program like Matt's, as we go through that, yeah, it's got some expense to it. You got to pay for a teacher. And I think, unfortunately, as we got so much into testing, we started putting so much resource into trying to get a test score rather than, you know, a practical education that's valuable for our communities. And Taylorville, for whatever reason, has held on to that. And I'm hoping it starts rebounding and growing again. That, you know, Matt's just been this wonderful example for other communities. And Matt, I think you had told me the cost is maybe about $200,000 per house, plus the donations, which I think maybe are 10–20% range. And I think you probably sell the house. Taylorville, you know, in Illinois, we're fortunate. You can still build a house, maybe 150 a square foot or a bit less. But do those numbers sound about right on the dollars? And
Yeah, if anybody says they're doing for under 100, it ain't no way. I wouldn't buy it. Because even for us, as much donations we get into, and no taxes, no labor, especially after this last, you know, big increase of everything going up. I think the first house, we, not counting my salary, we spent, and we get the property donated, just luckily these last three. Like that first one, I think we spent, it was like 175,000, and they took a cash offer at 165. And then this last one, I didn't even see the final number. The last number I saw was like 195, and we sold it for then we sold it for just under 2. So that we'll call it a break even. This one, we will be able to put a higher price, getting I'm going to guess they may start it off at 250s to try to hit 220s, because we're in a little bit better neighborhood on a lot and a half. But yeah, in Taylorville, you are not going to, except for being out by the lake, maybe, you are not going to build a house and come out over the top. We are not in a spec house community.
Well,
I had a quick question on since we're talking about the sales. Are you working with the appraisers to understand these components? Are they appraisers that have the green training, or is that
No,
part of your process at all?
they wouldn't even know what that is here.
Well,
Like
it'll be interesting.
we are the first ones. I mean, we have a couple houses. We did have a builder who did Energy Star buildings and stuff. And honestly, I think he built those houses, lived in those houses, then sold it and built himself a new one. And I think, and maybe there's a few people that caught on. Now, the good thing is this has caught on, and I'm literally standing there coaching, 8-year-old baseball, and the other coach is a contractor who's younger than me and went through this program, when he was in high school. And of course, we weren't doing this, but he's like, all right, so what are you doing? What are you doing with this? What are you doing with that? And then it used to start off, oh, you're using all that fancy stuff. I'm like, dude, it's caulk and tape, man. Throw in an ERV and you're done. Like, take your time and do it right. It's not as fancy as it sounds. Now, this year, we use Sega wrap and stuff, so we're getting a little fancier, I guess you could say. But yeah, there's nobody. I mean, it's literally, I don't know, maybe it's a little maverick of me, but it's pretty much, thank God the school, everybody's just lets me loose, and I'm just like, all right, this is what we're doing. We build it, and at the end, they sell it, and nobody's told me no yet. So until they do, I'm rolling.
Well, and they have another house on the tax rolls. And
Oh yeah,
in the Midwest, our general experience is that appraisers don't value the extra construction. And so as we go through this and some of the economics, we'll just kind of see what that spread seems to be. But yeah, I don't think it gets valued yet. And, and just as a program, I mean, I go out there once a month to basically get in Matt's way and follow him around and see. This year has been a lot of learning for me on that, get the heat pumps and stuff like that. As we get to part 2 next year, then I'll more actively hopefully be giving them some useful information as they install the components. But this year I'm learning a lot too, just seeing, the amount of time you've spent, Matt, finding all these products to test out, to try out, is just phenomenal. And so, but as far as the students too, I'm an educator by background. I'm a retired professor, but this type of program, we rarely get to have that active cooperative educational environment. When you have the usual classroom and you say there's only going to be so many A's, B's, C's, and D's, who's going to cooperate when you're helping somebody else get maybe the last A or B? This, everyone's helping. They need to cooperate to get things done. I learned by doing. It's just so much more effective. But the teaching Matt does, he's got to tell them it's going to be cold tomorrow, wear a winter coat. Don't come in sandals and Bermuda shorts for, working tomorrow. I mean, he's got to start from this end to that end. Here's what this tool does, how you hold it, how you use it. We don't have the backyard mechanics and farm kids coming in anymore. And so they really have a very basic level to start with, but they learn and they become proficient. And also on the education side, when you're doing book learning, which most of the classes I taught were book learning type thermodynamics and stuff like that, but that's basic cognition. There's these other forms we often don't get in school, like metacognition, like how to organize a group. As Matt, every day as they come in, here's what we're going to do. We're going to break up in these groups, but the thinking behind the thinking, how you organize, how you plan, and getting them in that routine. So they're thinking about that. And then finally, this epistemological cognition, but it's, you tell somebody, all right, you're going to build a house, and they're like, oh my God, how are we going to do that? But this thinking that you can do something that you haven't known how to do. I mean, that's Steve Jobs coming up with the iPhone. It's that type of thinking. He didn't know how to do that, but he believed he could. maybe tell us a bit about the house, Matt, and I mean, it's a beautiful house. I'd love living in it. I love the house that I live in because, you know, we designed and built it, and this one's somewhat similar, but this house, I think, could be in every community from, you know, our friends up in Canada, Newfoundland, down to the Florida Keys. It's just an excellent design for.
Yeah. So this was Emily Mottram design. She had actually the original design. Well, she has a few iterations of this house, so she calls it the Swallow House. So if you go on her website and search around, you're going to find that. This one was built 3 times as rental property up in Maine. And I remember when the first time I seen it, I was like, I reached out to Emily. I'm like, oh my gosh, that'd be a perfect one. And she said the same thing. She goes, I thought of you too when I made the post because the design is easy, the build is easy, right? And that was the idea. It was built as a rental property. So whoever was building these obviously was somebody who wanted a pretty good house, but something that was somebody could afford to live, rent, and then obviously I'm sure, you know, these people make profit off of. So, you know, open, you know, concept when you go inside, 3-bedroom, 2-bath, you know, 1,600 square feet livable, has a nice outdoor space, porch, that can be screened in and or just open air at the, and then, you know, your pretty standard 2-car garage, with, you know, and then we got our utility space and stuff. Hers was designed on a crawl or a slab. We moved ours up to a crawl just because being in central Illinois, we do, deal with tornadoes and bad storms. So we like to have safe shelter, which we detail I'm sure we'll get into, we detail our crawl space to be inside the house. So it is part of the conditioned space. So that was really kind of the only big difference from what she originally drew up to what we're doing. It's a double studded wall system she drew. We stayed with that, and we are moving right along.
Yeah. One thing I like is it's reversible, where we've got the smaller roof will be where solar is mounted, and that's a little bit less than 400 square feet, but more than enough for solar to make this net zero capable. And we usually say net zero capable just because you put a person in the house that there's no end to the amount of energy they like to use for whatever. But in any case, that's enough to power this whole house for the year. Or if you faced it, if the other side was facing south, then you have ample room for a lot more. But really a design that could be oriented in multiple ways, and it's not going to overheat, modestly windowed, and then just comfortable, easy to move around in.
Yeah. And for us, and since we are, you know, when the people in Maine, when they built it, obviously they had some free play there out in timber that they cleared out. So they were able to tweak the house with the solar panels. Us, we are literally the big sides facing east, the small sides facing west. And but we did take down 2 trees that were, they were in bad shape. They needed to go anyway. So it did open up that south view there for us off the edge of the road. Reducing any chances of our power lines getting taken out by storms. And 2, with solar panels potentially going onto the roof, that opened up that south view for us too, to help maximize. And fun fact, the mobile classroom I'm sitting in right now on the job site, with the lights on, with computers plugged in, is all solar powered. This whole house has been built off solar energy, like all the batteries, everything. We have had 0 temp power, and our meter on the wall still says 0 attached to the house because we put on solar on this mobile classroom.
So this slide isn't meant to be readable, but I think Brett makes them available to everybody. But just wanted to, we'll look at some economics, some energy performance, manual J, manual D considerations for the house. But to put it in perspective, this kind of defines contractor loose, who would be, say, not that long ago, but contractor of yesteryear, 10, 20 years ago, building a house, 6 ACH 50 on infiltration, a little bit thinner walls and not as good of insulation. contractor type who might be, say, more typical of today, a bit more effort to get it sealed, but maybe about 3 ACH, where some communities have been moving builders to hit, onto contractor smart, which, at least to my way of thinking, better performance, passive house type of home, which this one definitely will meet all of the standards, whether FIAS or fee. Less than 1 ACH 50, so as we get a chance to do a blower door, we'll take a look at that. But really the top level of house. And the thing that's difficult, I think, for most people in going through this is that there's not a common, say, basis for designing a house where you can get the economics, you can get the finance, you can get the energy, you can get the humidity, you can get the air quality. And what we use as a tool is something that we've developed called Zeros. We developed it 20 years ago. A graduate student of mine at the University of Illinois, we developed the computational engine, and then our company turned that into free online software. And so there's people around the world literally using this. And it's not a hodgepodge software. It's something that's been validated with DOE's best test comparison with big models, Energy Plus, Do2, Blast, Trenzis, but also extensive field testing. But the key thing is that it's simple to use. You literally can sit down and, once you're proficient in it, 5-10 minutes, do a design of a house and get good answers on all of these factors that pretty good house is based on: the economics, the finance, the energy performance. And so we'll look at some of those other things. I wanted to point out, and Matt's going to talk a bit about the foundation, because it's pretty unique what he did with that. But this house on the, assuming on the left of your screen, it's 2 lots down from my house. And it's what is still typical in too many of our communities: concrete block, uninsulated crawl space, some wrap that's kind of half-assed put on the house. And then you look over on the right and you see what Matt did: a really well insulated and sealed foundation that high school kids built, and then a really sealed, well insulated, well constructed envelope. Once the siding goes on, people aren't going to see the difference. And the interesting thing, those 2 houses you see on the left behind that crawl space, that concrete block, those are ICF homes. The subdivision I'm in, more than half the homes were ICF homes, but now the remaining lots, contractors are coming in and building these less expensive, poor performing homes. And people are going to pay many, many years of high utility bills because of that. And their health is going to suffer too. This part, oh, Matt, I think, do you want to talk about the foundation here?
Yeah. And I can share, I'll share a couple of quick photos or videos that will kind of be in the background too, to show you guys real fast. But in this picture, real fat, you can see that gray block. We use the Perfect block. If you guys aren't familiar with it, they're out of Arizona. They are an ICCF, which is insulated concrete, composite concrete form. So they've taken recycled, literally from industry, hospital, whatever, recycle, like foam coolers. They take it, recycle it up, and make the foundation block. And if you guys search them up, it's by Building Systems, I think is the company. The products is called Perfect Block. And I'll show some videos or pictures real fast here in a second to give you guys a little close up on that. But it is, the way it's made is to make columns and tunnels. And so I think it's like 60% less concrete goes inside of it. Yeah, Sean just said, got to see me demonstrate this at the build show in Vegas. This is exactly that. If anybody was just happened to be there at the build show in the construction performance zone. And what was cool is the kids did it all. They It goes together with spray foam adhesive, which is really cool. It is very strong. You don't have to, the blocks can stack on top of each other. It doesn't have to be staggered. We had fun on the internet making a lot of people mad with that because the strength is not in the form. The strength is in the concrete and the rebar. The inside does not care. But
Yeah.
let me pull up some close-ups and stuff, and probably got some kids in action and stuff here. Let me see.
As I remember reading 100% recycled styrofoam content. And so much better insulated along with reduction in concrete, but a real good structure.
Yeah, so the he'll be a good shot of this. Let me screen share. The I think the R value is, did that come up, Ty?
I can't
Oh, yeah,
I
you
see
can
it.
see.
Yeah, it's there.
Brett. Okay, yes, I got to ask Brett. So anyways, so here's kind of an inside look at what these blocks look like. You can see my cursor's moving there. There's these column and tunnels that are created by this block. So the structure holds it together, where typical ICF, you have they have like some kind of system inside to hold one side to the other side, right? Usually it's like a plastic support system, where this is that block is pretty much. Some people said they can't see my screen. I don't know.
Maybe it is still getting recorded.
Give it another try there, Matt.
I'll their side
Yeah,
too. So
yeah.
okay. Hopefully that's better fix it. Anyways, so you have a rebar system that you follow, obviously horizontal and vertical, and you can see their spray foam around there. They use a spray foam adhesive, and it is very strong. Like, you can go up there, you are not going to shake that wall. You would probably bust the block before you busted the seam when it's connected. It used, I don't even remember how much concrete. I think we used like 2 more yards more concrete in our wall, and our foundation wall, than we did in our footings. We did use the fab form footing, if you guys are familiar with that, underneath a fabric footing. That was pretty cool too. But as far as performance wise, the perfect block was cool, man. It was easy to use, is easy to, if the block is low, shim it with a shim. If the block is high, rasp it with a rasp. It's literally that easy. Or you can cut it like with a sawzall, with a hand saw. It's foam. It's looks like concrete, so it blows everybody's mind, especially when you post on the internet and nobody reads what you write or listens to what you say. They just automatically go to, why did you not stagger the seams? What's that? Why did you use spray foam? Why, everybody assumes it's concrete. So that was a fun thing to play around with. But yeah, it's we waterproofed the outside with a spray on kind of rubberized membrane, and then inside we left as is, but we did conceal or encapsulate our foundation, our crawl space, and we have a house standing on it. It's performance wise, it's definitely going to outperform just a normal concrete block CMU foundation, or even concrete. We didn't have to take any extra steps of adding insulation. It's already on there. You would have had waterproof anyway, so very easy. I think it's one of those things where if you did this a couple times with your crew, you'd get pretty proficient pretty quick at it. The kids rocked it out. Now, of course, you'll have to check, depending on where people are listening from, if you're able to use this system in your zones, by all means, check with your engineers. I'm not that person. I can't. I think dollar value is 27, Tony. I think that's what it was, I believe. And this block is the symmetrical block. We had 2 inches of foam on each side. You can get an asymmetrical block that has, I think, 3 or 4 on one side, 2 on the other. I forget how it is. And we use I believe ours was a 10-inch wide block with an 8-inch core.
And so, yeah, so, and maybe, let's see, I don't know if we can go back to see when we get the screen sharing
You want me to undo mine?
back. Yeah, I think so. It's hard for a regular builder to risk new construction techniques like this, but you have a program in a school where then someone like Matt can try this out, and builders and contractors can come in and watch it while it's going in, ask him questions, see if he'd ever do it again. I mean, this is really how a community then can investigate new techniques and then start to train current builders on these new techniques. And I think that adds a lot of value to a community. We won't go through the details on this, but I want to say that in our newsletter at buildequinox.com, you'll see over the last several months, and it's going to take a few pots of coffee to go through it, but information on the economics, on the finance, the assumptions used, but this is all out of this Zero software. And with that, looking at, say, contractor loose, tight, and smart building a home, maybe there's about $25,000, $30,000 difference in that upfront capital costs. You add solar, maybe another, with current solar tax credits, and in Illinois, we're fortunate with what we have called solar renewable energy credits that add another 20, 30%. But to make this a net zero house, there's maybe about a $30,000, $40,000 difference. But when you look at the lifetime energy costs, and Zeros let you put in replacement costs, so water heater every 15 years, a furnace or a heat pump every 20, windows every however many years. But you put in replacement costs on top of capital costs and then lifetime energy costs, you can see that on the life cycle costs, assuming 100-year costs, the solar powered net zero pretty good house is a really good deal. A couple $100,000 less over, and that's because of energy costs. And going on to finance, just even if it is the better deal economically over its lifetime, what's the monthly going to look like? Because your mortgage will be higher. And again, in Zeros, it will give you the finance, the monthly expense. And if an appraiser did appraise this higher because of more insulation, more expense, but our experience, at least at this point, in a lot of areas, is that appraisers don't care what the insulation is, or it's got solar or this or that. Some communities are getting to where they do. So even though real estate taxes and insurance might be higher if the appraisal were higher because of these benefits, most likely you're going to be paying the same on real estate taxes for a high performance net zero than a conventionally built home. But I've put that in so that it does scale with the quality of the house in this. And you can see that the total monthly expense, higher mortgage, but lower utility bills. And as a net zero home, at least around us, our utility is your customer service fee. $20 a month is what you'd be paying, relative to what might be, say, $200 to $300 a month on average with our current electric rates for that. So in any case, it takes a lot to put all that together, but that's really the story, is that you build this high performance, pretty good house. You're going to spend a little more to get that quality, but you're going to spend less per month, and you're going to save a whole lot over the lifetime of the house. Matt, you also, in the crawl space, as well as on the footers, did some unique things.
Yeah, you want me to, the footings?
Yeah, did you like the fast foot?
Yeah, the fast foot fab form. If while we're talking here, I'll see if I can pull up a close picture of that. Yeah, if you guys have never done that, it's just a fabric footing. They've been around for a while, actually. They sent this down. The kids, so this is the first time the students have ever done, I and the students have done the foundation for the house. We've always had the foundations done for us ahead of time. And it was a lot of fun. And we picked these systems because of the ease of install for them. I'll share a picture here real quick. It's kind of one of the, it was one of those things, it's so pretty you hated to cover up, right? If you guys have never done this or been around it, here's, if you guys can see the picture I have, here's this intersection where it kind of shows the fanciness that we had to do. And the kids did an awesome job. The fast foot, it's a fabric, it's marked off. You put up your form boards, I guess you could call them, but all they are elevated guide rails that you tack onto. And we used very little bracing, which is awesome. The stakes were just 1-bys. We didn't have to use any extra kickers and stuff because the fabric way in it works as it pulls away, it also pulls it in and holds everything in place. Of course, we do have a rebar system that we put in as well, with verticals and our horizontals inside the rebar or inside the footings themselves. And we had our verticals attached, sticking up where our blocks had to go over top of. So the kids did an awesome job. You may see some of my personal pictures here as I pull some stuff up, but we put these little clips on. That's what held our rebar up. We tied them off, and then we did a pour. And one of our local contractors literally came and watched the entire pour go on. So yeah, you can see we have students in action here. With the pump truck, and back in the corner, the bigger guy in the blue shirt was a local guy, and he's like, all right, this is how we're doing ours from now on. Now, again, check with your local engineers on how, we were able to do our footings like this. So it was no issue and stuff, but quick, easy. The kids did it all, and everything came out nice and square and plumb. Now, of course, we do take our time to make sure everything goes right to the best of our ability. But yeah, another cool thing, another cool solution and company we got to team up with, another product that nobody else has used here locally. And it's very inexpensive, and it is way better to build your form, nicer building your forms out of 2x4s rather than 2x12s. If you're ever,
and then you reuse the 2x4s.
What? Yeah, the 2x4s got used as either temporary bracing and or top and bottom plates, even like all that material got reused.
Matt, now I don't know. Let's see, if we go back to me on screen share, I don't know if I have to.
No, you're all set, Ty, now.
Okay. I'm not in control, but we'll see. Anyway, that we're going on to energy on these, and again, I don't want to go too deeply. These reports go into a lot of depth on these. But as you go from this contractor loose, maybe 10, 20 years ago to maybe current to this more advanced, but happening all around the country. I mean, Vermont, Maine, New England, been there, done that. A high performance house to me, the definition to me is when the climate load becomes less than the human load inside. The load for hot water, which is a large load, the load for plugs, and the plug loads that are used that I assumed in these zero models is that there's 3 people in the house, and on average that a person is about 50 watts of continuous electricity, computer, telephone, or cell phone, lights, stuff like that. And then 200 watt base, which about 100 watt, 50 to 100 watts is refrigerator, and then other things that are going on in a house over time. But you can see that adds up, 3,000 kilowatt hours a year. Domestic hot water going from today's electric hot water heater, whether instantaneous or a tank, to today's heat pump water heater, you cut that energy to 1/3, and it's good in all climates, whether you're up in northern part of Canada or or down in Florida, heat pump water heaters are the real deal and need to be in every home. And this roughly 2,000, 3,000 kilowatt hours of energy savings in hot water, that's about 6,000 to 8,000 miles of driving an EV. This energy is significant for using in other ways. But the way the house is sealed, the heat pumps that we're using, the dehumidifier, the way that's integrated in, it really has a multiplier effect in reducing the overall energy to where the climatic load is not very high. And then when we look at the energy needed, the heating and cooling capacity needed for the house, and then dehumidification. And as I think more and more people are realizing, a lot of our heat pumps are not doing such a great job in dehumidifying, or when you get to that season when you don't want the cooling effect with the dehumidification, that adding in a separate dehumidifier whose purpose in life is to manage moisture, that this is a pretty significant load. Somewhere in the range of about 40 to 60 pints per day would be typical. And so under design day conditions, for us about -7 Fahrenheit in the winter, 105 in the summer and getting hotter, that we're somewhere in the range of about 2 tons for what Matt's building, 1.5 tons heating and a little bit less than a ton, about a ton with the latent load on cooling side. And so with that, as we look at the mechanicals a little bit, we'll do that more in depth next year, but that about 2 tons of heating and cooling capacity on the heat pumps will manage that. We already talked about the foundation. You did add sealant around the foundation, Matt, and what were you doing with that?
So yeah, we found a kind of a water-based rubber membrane. I forget exactly. It's been such long. I know we have some buckets in here, but I forget what it all was. But very safe and kind of, this company's a very eco-minded company. So they're all, the adhesives and everything, they're in what we use. They're definitely trying to, keep that in mind, being cautious of all that. So it was, we just ran it through our old sprayer, which next time we run it through our new sprayer because it does way better and you don't have to clear out the nozzle as much because it just cleans up with water. So what we did, and then you kind of seen that picture, we ran fan fold around it, just an expensive fan fold, and that's all that was, is a protection barrier to protect the waterproofing barrier. So when we backfilled with dirt and everything, we didn't beat that all up. So we have below grade, we just have a row of fan fold, and that's just really a protection. But yeah, we went around, sealed that down, which worked out good, sealing. The only thing we didn't master, and we won't have any issues with, but using the fast form footing, like tying that into everything so everything's encapsulated. That was the only thing that we really kind of had problems detailing a little bit with our system. But we have drainable rock around the bottom. We have on the inside, we have our drainable rock with sub pump and tile work and all that good stuff. So our foundation, we've gotten hammered with rain and it stayed dry. Yeah. Actually, the only water that got in there in our crawl space was because the water wasn't covered with the roof yet, and it came through our subfloor that we had to deal with. But hey, that's construction, and we don't build as fast as a normal crew and stuff. But no, yeah, turned out great. Foundation, I couldn't be. I would, if I'm building my own house, all day long.
So, on the comfort conditioning, what's often called manual J, but in running zeros, to just look at these subzones to see what kind of heating cooling needs for the master bedroom suite, 2 smaller bedrooms along with the main living open area, that it breaks it down. And while I don't show the detail for each of those rooms, you'll find in the reports that if 4 people are over in the main room and nobody's in the bedroom versus 2 people in the master bedroom or 1 in one of the smaller bedrooms, that you can do that type of analysis and just see, do I need 1,000 BTU per hour in this space, 8,000 BTU per hour heating or cooling? And so what we're going to install next fall will be 2 1-ton mini split heat pumps, low temperature heat pumps. One will be a ductless in the in zone 1, the main open room. And then the other will be a ducted unit that's integrated with the smart ventilation unit and the dehumidification unit. And we'll see a sketch of that configuration. But those 2 heat pumps, most of the time, we won't be at design day conditions. We'll be at maybe half of that or less throughout most of winter and summer. And the old adage that that if you oversize, you have a less efficient system doesn't hold with today's inverter drive speed control heat pumps. 2 1-ton heat pumps operating at 50% load operate 20 to 30% more efficiently than a single 1-ton heat pump operating at 100%. It's not like the old 150,000 BTU per hour furnace that's bang, bang, on, off, and it's just getting running when it's then shutting off. That's inefficient. But today's speed control heat pumps, when they're running at part capacity and you put 2 of them in, you get redundancy, you get resiliency, and you get higher efficiency with them both running. And that's part of what this does for this house, is elevates the efficiency above what the SEER value is showing for that unit. Matt, you put in double stud walls on the house, and these pictures kind of show you Matt is actively involved. You know, when I would visit the site, he's up on the scaffolding, he's over in the garage putting in the attic. And these are all 3 different groups of kids he has working around, and he's regularly going around climbing up and down. So he gets his exercise. But with the double studded wall, why did you decide that, and what do you think? Ooh, mute.
We can't hear you, Matt, if you're talking.
Yeah, sorry. I was taking care of a few things. Yeah, so the double-sided wall, one thing was, if you guys are familiar with Ben Bogey, which many people in this arena probably have heard his name or are aware of him. He's a builder, big double-studded wall guy. Emily Mottram, the architect, also a big double-studded wall fan. In fact, the question just got answered. I answered, you know, why didn't we take the block all the way up to the roof, right? You absolutely could do that, and it would be a very well performing house and solid house, just like any other, you know, ICF house. Absolutely could. I'm a carpenter by trade. Doing the concrete foundation was a lot of fun, but I want to build, right? Plus, the kids love framing, because I mean, think about any builders that are in the group. When you think about building, since we were a kid, it is wood framing house, right? It is hammering nails, wall, you know, boards together. That is building. To, you know, in your head, right? You don't think of, you know, maybe if you live in like Italy or something where there's a lot of concrete and plaster and stuff, you think building maybe a little bit differently. But, you know, here, Midwest especially, building a house, you drive by, you see a stick frame, sheeted, you know, wood structure. So the framing goes so fast. It does not take long to frame a house. It is, even for us being brand new, the kids love it. They learn the layout. They get mad because they have to tear apart the wall 3 times because they messed it up because they put the stud on the wrong side of the line. Or maybe I did a layout for them real quick and I marked it wrong. And then now they got to fix my mess up because I'm in charge and I don't fix my mess ups. I've done that already, right? They got to learn from my mistakes, you know, how annoying that is. So teaching moment, right? So, double studded wall, honestly, is something I always wanted to do. We've done, every time we do a wall assembly on a house, I do something different for my own reason. I get bored easily and I don't want to be bored at work. So this time we built a double studded house because I have never built one. And ultimately, that's how that decision came about. It just happened that we had the luxury of the plans already had a double stud wall on it. Of course, we're going for high performance. And the kids got another round. And technically, we do have high school students, but we also have one more class of Lincoln Land Community College comes. So we have 3 crews building this house. So you literally could just frame a 20-foot section maybe, and that's all you get a frame. Well, now everybody got to do framing twice. Plus, we got our interior framing that we actually build after underneath our air barrier and everything. So getting the kids on framing one more time was just an extra bonus for doing a double studded wall and stuff. And I do a video walkthrough. I mean, I could show it in the background. I won't play sound on it, but it's kind of highlighting the wall system and stuff. So what we did on the outside is just a 16. It is a 16 or 20. Sorry. The outside wall is a 2x4, 16-inch on center wall. The inside is gapped 2 inches. We have a 9-inch thick total wall, and we did 2x4, 24 inches on center, which will get a Myrex. Actually, we've already got it on there, Myrex from Stiga for our air barrier. And then we did we'll do purlins or furring strips, strapping, whatever you call them in your area. 1.5 inches will create our service channel and also protect when we put our drywall on, protecting our air membrane. So yes, it does add cost, it adds material, but in the sense of for the students, it gave them a few more hands-on things, because even though we build a whole house, this is still a very introductory class to building a house, because you do framing, you do roofing, you do siding, you do foundation, you do mechanical, you do electrical. So you get to try it all, but you're never going to become a master of any of it in this class alone, even doing 2 classes worth, because technically if you do 2 classes, you build a whole house, but you only do one thing or each thing kind of once, install windows once, right? So yeah, double framing wall was just, hey, let's do something different. I'm a carpenter. I love framing. The kids love framing. And that is,
and
how that
those
happened.
economics are included in that cost in the modeling. So a thicker wall, thicker insulation, that's part of that cost model and the pretty good house. And I think it's really neat that, you brought in folks from the community college, that you've made that link. And so it's not just restricted to high school, but it's great to merge that with their program. On the duct sizing, again, too many numbers and stuff, but these are here for you. And then there's reports that detail up, how much flow goes to each room. And the main takeaway from this slide is that in today's house, as we get the loads down, we're used to thinking of the airflow in a house is because of the central furnace. You need 1,500, 2,000 CFM or so of airflow whirling around your house. A house like this, design day conditions with today's heat pumps, you're talking 200-300 CFM of airflow on the coldest day of the year. And when it's not so cold, that airflow for comfort conditioning is lower. Now you need to be thinking about air quality just as much as comfort conditioning, because most of the year, and this shows the house with 4 people in it, we would recommend about 160 CFM for this house. ASHRAE is much lower, but ASHRAE is an odor standard for ventilation, not a health standard. But you can see that they're pretty comparable, and most of the year air quality, ventilation flow, recirculation, filtration, fresh air purging of the house, these are the dominant flows. And basically what it comes down to then is that you're going to have 6-inch, 8-inch ducts to deliver air to the house. And this shows up in the mechanical room. There'll be the smart ventilator with the 1-ton ducted heat pump, and then a ducted dehumidifier, an 80 pint per day, and then a 1-ton ductless in the main living room. And very simple controls, very simple mechanical room, very compact mechanical room. And then returns, keep it simple, 2 8-inch duct runs coming from the odorous, the wet areas, bathrooms, kitchen, and there'll be, as Matt said, crawl space is a nice space, and it will have some flow through it as well. And so its air quality should be as good as the house air quality. Matt, do you want to talk some about the wood fiber insulation you've used? And it's really unique, and that's when Emily visited, but it's really an interesting product.
Yeah. I actually just pulled up those pictures and videos. So I'll put something here kind of running in the background for us. If you're not familiar with Timber HP, that's okay. They are just kind of on a relaunch, or they've not really relaunched. They've just launched. Many of you may be familiar with wood fiber insulation. Is it Gore-Tex? I forget the brand. Anyways, it's been around for a while, obviously in Europe, and I do know there is one brand. I think they're more Canada, maybe. But anyways, Dan Edelman, one of a very good friend of ours, he is their marketing or business guy. He's the main guy for business development. Anyways, very good friend of mine. He just joined on to their team here this past, I think, last fall maybe or something, and he they donated the entire insulation package for us in our wall. So we did a blown in timber fiber fill. I will put the kids and the students are the ones who did it. We got trained. Ty was there. We had a whole slew of fun guests, and we got Dusty, right? It
wasn't bad though,
no, not at all.
Yeah, I mean, compared to like blowing cellulose and stuff, it was. I mean, you still want protection when you're right there putting it in, but it wasn't. It was less dust.
Yeah. Well, and it's since it's wood fiber, it's just so different. Like, there I'll have this playing kind of. You can see Matt.
The bats had a real rock wool type density feel to them.
Yeah.
And
yeah, very dense, very friction fit. So, and if you actually, Dan Edelman used to be with Rockwool, is now with Timber HP, and so he's really helped a lot with development of, with the product as far as the workability of it and stuff. The video that should be playing, this is Matt Damon, not the actor, but the Timber HP guy, and he was training the students on the dense pack. So we put up all the netting and stuff. He came in and walked the kids through how to do the dense pack, how to, what are we looking for? And then these students, and I'm sure I have video somewhere or pictures, they went around, and in fact, once they had to leave, we finished the rest of the dense packing on our own. So the walls, are all dense packed with wood fiber fill, and we'll blow loose fill back up into the attic. While I'm talking here, I'll pull up, see if I can pull up pictures. You may see some fun family pictures too as I'm going. Oh, here we go. Here's a close picture. And here is the fiber bats, their batting insulation goes in super dense. I mean, it's very dense. If they'll do a demonstration where it'll bend. I mean, you can snap it in half, of course, but it'll bend and hold itself. Very easy to cut. Like I said, if you've ever worked with Rockwool, and their comfort bats, performs very much the same way as far as a install goes. I would say probably the biggest benefit on a install side is it's like Rockwool never bothered me, but that's because I was always used to fiberglass, which was itchy. This is not itchy. It is just wood fiber stuck together, right? It's pretty cool. They've done everything for, bug resistance, moisture resistance. You pour water on it, water runs right off of it. Fire resistant, things like that. Obviously, if you had extreme fire situations that you deal with, Rockwool's probably going to win in this situation. But they've done all those testing, they've done all that for their warranties and how it's supposed to perform. And it was a lot of fun. Ty was there, we had a blast. Emily was there, did all the install, and the house smells like wood dust.
The interior room that they use bats in, I mean, for acoustic deadening, it was like walking in a recording studio. I mean, you definitely would would see that, or you notice this was a quiet room, and
Yes.
so very interesting. I hope folks check that out.
Yeah, in Magnus
Windows
there.
you used.
Oh, I was gonna say it is. They have done moisture
Oh,
resistant, rot resistant, all that good stuff too. Yep.
yeah, and on Windows you used very high performance Windows, and one of the great things, and when you go through something like zeros to then model the cost of, well, what if I want to put in 100 square feet more windows or not? And you're getting the energy performance, you're getting the cost performance of a home. One of the things that's perhaps disappointing to people who like lots and lots of windows is that you basically find out windows really have a hard time paying for themselves. The main reason you want windows is for light and delight. Aesthetic value has, who would want to buy a house without any windows? But in many cases, that's the most economically optimized house. But we do want to see outside, and daylight is the most comfortable light for our eyes to be in. And there's health benefits to light. I mean, we know about SAD and other syndromes with too little light in the wintertime. This is a really well daylit home, but modestly daylit. And to me, something that's, say, 10 square feet of either wall or floor per window square foot is where you want to be. It'll be well daylit, and it also makes it so you can afford better quality windows that will give you high performance. And so I thought that was great that you were able to do that. And here's the installation process, Matt. Did that go okay? And
Yeah. So now we do have a thicker window, and we did decide to stick with, especially students learning first time and stuff, we did stick with a flange window, which put it to the outside edge. I do know if we're doing full passive house and stuff, that probably would have moved in some into our cavity. But we've found that we've had no issues with condensation or anything when it comes to doing this with a thicker wall in our area and stuff on all three houses and stuff so far. Now, like I said, if we were going more stringent, I believe we would have to move our windows in. But for students
yeah,
learning,
I visited this manufacturer in Colorado, and they've got some pretty impressive demos that I don't think you're going to see condensation. Their frames are excellent, and the quality of the materials.
Yeah. And I believe they even stepped up. They had to step up their game on some things with they had some small quality things, but I don't think it was performance wise. I think it was more of kind of an aesthetic or kind of thing. But they came, they look great. They are tilt and turns, which is the first time we've ever used them. First time well, that's not true. I've seen them in person. First time I've been in a house with them. First time my students obviously have ever seen them. So everybody's had a lot of fun with that because they operate in such a different way. And the kids, I mean, our installs are very typical as far as leaving the bottoms open for drainage and caulking, taping them in. And then, of course, our air sealing will be done from the inside of the window and stuff. They seal up crazy tight. Doug Pruce, who helped us work out or get the order done, and Alpen was nice enough to also give us a discount on these windows. I think around about $1,000 it came out to be. They did come from Denver, so they're built up at a much higher elevation. So they come with these special balloons on this little tiny metal straw, and we learned all about that. And our students, because they're in high school science, understood right away why something built at a higher elevation coming down to us had to have this special balloon. They guessed it right away for that pressure to somewhere for the gases to go, so they don't blow out the windows as they travel towards the Midwest. And Doug showed these kids how to pretty much be the technicians of these windows. The kids can adjust and fine tune these windows better, and I did. They had to teach me because I was like, apparently I didn't pay attention close enough or whatever it was, but I had kids that were tweaking these things. So the good and bad thing is the windows do move, a lot of moving pieces, which is bad because there's more things that can go wrong. But the nice thing is you can dial these things in very well. And I now have a handful of kids who hopefully get to see a tilt and turn again, but can fix your tilt and turns if there's any more around us.
Yeah. Well,
So yeah, I wanted to go back to the foundation, Matt, and a question that came in on that, and it was just a question more about the here we go. The let me make sure I have it right. What material is applied over the ICCF rubber membrane as protection before backfilling?
You know what? Oh no, we took the buckets out here. I'll have to find it. The company was out of Ohio. If you go to Perfect Block, if you're on their website looking around, it was what they recommended in their install. That's how I came about it. Like I said, I believe it was like a rubber-based or a water-based, like rubberized polymer. I forget all the scientific words that went with it. And I apologize. Man, I knew it was from Ohio. The people were great to work with. And they make the batches up as the orders come in and send it over. And it's one of those things where if you're using it through your sprayer, they give you the tips and the pressure and all that stuff of how to do it and stuff. The kids did the install. We did wear like a Tyvek suit because we didn't want to get them all over our clothes and stuff. And I think we still had them wear a mask just because you don't want to, doesn't matter what kind of base it is. You don't want to breathe in something that's, you're gonna, don't want to close up your lungs with.
But it wasn't fumy, and it was
I don't even remember the
rubbery
being like a
tactile
smell.
Yeah.
I mean, there may have been a slight smell, but
yeah.
It was no issues. The kids didn't. I mean, it worked great. Like I said, it's just a matter of us first time using it and stuff. So just getting used to how I do it next time. I just make sure I use a better, more powerful pump sprayer than what we did the first time, because we just always seemed to be clogging up our nozzle. And I think we had a slightly smaller orifice size than what we really needed too.
And a follow-up to that, was there a board applied over the rubber membrane?
Yeah, so they recommend just throwing a fan fold, inexpensive fan fold insulation board over the top of it. And that was really just for protection of when we did our backfilling. So that way we didn't beat that up as we dumped dirt and stuff into it, or drainage drop down towards the bottom and stuff. So
I'm trying to see some other questions in here just to stick with the wall assembly conversation real quick. But I was curious let's jump real quick to the future, to operations. And I've got two specific questions there on that, and it kind of jogged my mind a little bit with something you said at the beginning, Ty, and something you said. So the question is, Ty, you mentioned that the home will be net zero capable, right? So like you're building it to be net zero, but it has to be operated that way. And so I think the question is there a component, especially for the sake of the students or the next set of students, really, to be educating and training the new occupants on how to operate their home and how to maintain it, how to maintain these systems, how to live it so they can hit the net zero target, and then to follow up with that, to verify some of these performance targets that you kind of showcased in your data there, Ty. Are they actually hitting these, air quality and energy targets? Are you monitoring that? And can that be used as a lesson learned for the next set of students? So kind of a big question, but it's really more getting into that operational piece. So
first on the design, something like zeros, we've used that with high school students and junior high students, Project Lead the Way type programs. as well as, others, college students and beyond, and they pick it up really quick. And so they start seeing the interplay of costs and energy and that. Then regarding performance, prediction, costs, this has been a great project to just get to see in real time the construction going on with then what the modeling is saying. And at the end, we're going to be following that. But, like the smart ventilation system in the home, the Serve 2, it's all online. Has been for, we've been doing over-the-air upgrading like Tesla as long as Tesla, 10 years. And that's what's allowed us to be a small company in the middle of, Illinois, but having units all across North America in all climate zones. We're running the largest indoor air quality experiment that's ever been done. Mm-hmm. So we're seeing what is needed to manage air quality in homes of all types all around. Yeah. So that data is there. Plus, because of our research background, we run a lot of field experiments, air quality in churches, air quality in bars, air quality in driver motor vehicle centers. So we're actively looking at that. And in the housing side of things, in Vermont, with Vermont and Efficiency Vermont folks, that we ran a 2-year study of 13 identical homes, Vermont homes, but very non-identical people. Mm-hmm. And some people didn't even look like they were breathing in their house, and other people, there wasn't enough fresh air in the world for them. They were maybe rebuilding their motorcycle in their living room and, all sorts of solvents and things. That 2-year study, 13 homes, hourly data on air quality, comfort, temperature, humidity, and then every energy circuit. We found that our predictions were very accurate, but on top of that, those homes were very, on average, very similar to what we predicted. I mean, within 5%. Yeah. And so we're very confident that what we're predicting on this house, as well as hundreds of other homes around North America, that if you have the average person, but the average person doesn't exist, just like average weather doesn't exist, design doorways at average height, because half the population will be pretty upset and the other half might be okay with it. In the same way that in homes, you don't design for average heating and cooling. You need to design for some people that use 3 times the heating and cooling for whatever reason. Yeah. But our philosophy is also that we don't want to beat people and say, look, you're not hitting net zero, you got to turn this. We want people to live the way they want to live. Right. If you're beating on somebody saying, oh, you got to turn that light off and do this and that, you're adding stress to them. And that's the opposite of what we want. We want people healthy and comfortable and de-stressed. Right. So your home is automatically taken care of and simple. Yeah. But what these online tools and control also allows us is that when somebody has a problem up in Newfoundland, we can go online and say, oh yeah, let's run these diagnostics. Yeah. Hopefully it's not us, it's someone else, but we can give them the information on what's needed to fix it and take care of that. Yeah. And get them back to feeling comfortable.
Well, and Matt, maybe that kind of segues into, stick with that thought on the operational, but segues into the question I asked you before we started, right? That sort of what involvement would you wish to see sort of with students on the design side? But then thinking through, like, are you going to take your lessons learned from the operations of the homes you've done to kind of use that to help influence the next one? I mean, where does that come into play, or what kind of thoughts do you have on that?
Yeah, so unfortunately, we don't, the design part kind of happens pretty much out of school, right? I got everything figured out by the time we come. I would love, we had once it, ideally you have a school, you go to your design class, you learn a little bit of design and architecture, and then also you can maybe learn design and mechanicals and blah, blah, blah. There's so much, all those things are their own training and classes, right? We all know this. It's HVAC is where I have the least amount of experience, so I love learning all about this. So with that said, the kids don't really help out in design, but we do go over everything we kind of do. Like we were kind of talking about, why is the door swing this way? Why is that? We put the switch here. Why did we build a double studded wall? Why are we putting caulking on both sides of our sill seal when we're doing our sill plates and stuff? So we go over the why of everything we're doing that goes into the design of whether it's the wall assembly or the entire house or it's the kitchen, right? So we talk about all these things. We also talk about, project management and stuff as we go through and stuff too. So they get everything kind of sprinkled in, which I'd love if it was a whole part of an entire curriculum. But of course, when you're building a whole house, that takes up everything. That takes up all the time. And we're already here for 3 class periods. Now, the other thing we do also do when it kind of talk about to get inside of the indoor air quality and things like that, is we're kind of talking about, we have an indoor air quality. As soon as we're sealed up, we have an indoor air quality monitor that runs inside the house. The kids can see. I sit there and by myself, it's at 99. They come rolling in and it drops down to 69, So, and then, they get as, why did that happen? Well, you guys open the door up. Maybe that's good. Maybe that's bad. You guys, who knows what you're kicking off your shoes, kicking or stirring up the dust in the house, or the carbon monoxide, the humidity, obviously, right up, it goes up fast. You bring in a dozen kids into the house and, we start breathing. So, they get to see that kind of stuff. And then we talk about why that matters. And we talks about, okay, so Ty, and then you guys are installing an ERV. Why does that matter? We're putting an ERV because of this thing over here. And because it's so tight, because you guys are going to run a blower door test, which we have our own blower door. So it's one of those things where they kind of get to sprinkle all that kind of stuff in, and we tie it all back to the design in the matter. So it's, kind of the how and the why and things like that. If that answered that question.
No, it did. Yeah. Thank you so much for elaborating on that. And it's, how often is it that workers are considering their air quality, right, during construction, and so that I think is important. So I appreciate you sharing that. I mean, I think about, these heat waves that are coming, even before that, you thought about worker safety during COVID. So I think that's a new one. I had never heard of. I'm sure it happens, but I've never heard of during the construction process, someone having the air quality monitor and at that point, right, and showing what's going on. So thank you for sharing that. It really made me think. So one other thing you said, Matt, that stuck out to me was you mentioned you're in a solar power trailer, you're using renewable energy to build the house. And it makes me think about the shift, from operational carbon, which has always been the focus, right? Net zero construction, to the embodied carbon or upfront carbon going into the construction of our homes, right? And I was thinking about, obviously the construction practices, and I was curious if that extended into you using, devices and systems and vehicles even that would otherwise be diesel or gas powered and switching them to electric and powering them with solar. Like, is that something you're getting into when you say this is a solar powered build, or what extent are you going, down that road?
Yeah. So we obviously we're in farm country and stuff. So, we got plenty of guys with big trucks and all that stuff, but we talk about the ability that this house could charge cars. We obviously, the kids know that we're working off solar. They see the solar system. We talk about it, all that kind of stuff. So we get into, and again, that's places where I'm still learning. And trying to understand. So, we bring in like the professionals, or we talk to Ty and things like that. So it's one of those things where we're seeing more and more solar pop up around us and stuff, of course, because of what's going on in Illinois with the brakes and everything.
Sure.
And but we talk about what this house could potentially do, like the performance side.
Sure. Okay, fair enough. So well, with that, we are at our time. And I appreciate you all sticking around to talk a little bit more and answer some questions. And before we, I guess, wrap up, just real quick, Ty, where can people go to, reach out to you and learn more?
Well, both down at the bottom there, Ty at buildequinox.com, and then buildequinox.com as our website with tons of information. So check that out, and for sure ask us questions anytime.
Sure. And Matt, where can people go to, reach out to you, learn more, or, maybe support your projects if they want to?
Yeah. I'm very active on Instagram and LinkedIn. So LinkedIn is just my name, Matt Bloomquist. There's just one O in Bloomquist, even though we say it a long O. And on other social media platforms, you're going to find me as Build, Learn, Teach, whether it's Instagram.
Yeah.
I've put stuff on TikTok too, because that's where the younger generation is. But full disclosure, I just copy Instagram over to everything. It starts at Instagram. So that's just kind of where I kind of got plugged in with everything. But I'm pretty easy to find. But yeah, LinkedIn, just use my name. Facebook, use my name. The other things, you just do Build, Learn, Teach.
Yeah, Matt, it's always great to, I see some of your updates on LinkedIn. I love it. Love learning more and seeing what you're doing out there. So I encourage everyone to go follow you. Go check out Ty at buildequinox.com. Thank you so much. We're off next week. Have an amazing 4th of July holiday for all of those of you in the United States. For those of you outside of it, enjoy your time next week too. We'll catch you in 2 weeks on the next session. So take care. Be well.
Yeah.
Thank you all.
Thank you, Brett. Thank you, everyone, for participating.
All right. Bye.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.